So please submit your attendance in the LMS. As for Estremos, yes, it's okay. She can still submit her attendance. Okay, so everyone, please check the LMS I have attached there in the file for today's topic, today's lesson, and also the laboratory worksheet that you need to print and bring it on Thursday, okay, for our laboratory activity. Okay, so let's get started, everyone. Let me share my screen for a moment. So again, to those who haven't submitted their attendance yet, kindly check it in the LMS. Okay, so I guess we're good now. Do you have any questions so far? 1A? Wala itong utana? Okay, 1A, are we good? Okay. Okay, so in our previous discussions, we talked about the different states of matter, the properties of liquids. But this lesson, we will focus more on the properties of solids. Okay, next week will be your face-to-face examination already. But I think you were already informed. They, yeah. Yes, okay, that's right. Anyways, your teachers, subject teachers, will still give you some instructions this coming face-to-face meeting. Okay, so again, we will be dealing the properties of solids this time. So our lesson will focus on these learning competencies. So we have described the difference in structure of a crystalline and amorphous solids, describe the different types of crystals and their properties, ionic, covalent, molecular, and metallic. So before we proceed to our lesson proper, everyone, so let's have this short activity first. Okay, I want you to type your answers in the chat box. So below are two pictures showing unique properties of a solid. Analyze them and answer the questions that follow. So first picture, it shows a cotton candy. The other one is a diamond. Do you think these substances are alike? Okay. 1A, do you think these substances are alike? You can type your answers in the chat box. Yes, okay. What makes them alike? We will check your answers later. Again, what makes them alike? Okay, both of them are solids. Okay, what about their differences? What differentiates the two? Again, what differentiates the two? Unsay kalahian nilang duha? Okay, soft ang cotton while hard ang diamond. Hardness and tenacity. Okay, very good everyone. Thank you so much for sharing your thoughts. Now, why do you think they have different properties. Lain-lain ilang properties. For example, the other one is soft, the other one is hard. But they are both solids. So how do different, the structure of their particles affect their properties? Okay, so let's proceed now to our lesson proper. We'll answer these questions later. So our lesson again, this will focus on the general properties of solids. Okay? So in our previous, in your lower level years, you have already learned the basic concepts of solids. Okay? So that includes this one. Can you see my screen, everyone? Basic concepts.
Yes, ma'am.
Yes, okay. So, naano to siya sa basic concepts na slide. Is it correct?
I did din, ma'am, general properties of solids to the Japan, ma'am.
Okay, wala siya nimo. Okay, so let's have here the basic concepts of solids. So we know we have learned this one in our lower level years that solids, they have definite shape, they also have definite volume, and they have strong intermolecular forces. Some solids are less compressible, some are not they cannot be compressed. Solids, they do not feel the shape of the container. Okay, these are the basic concepts of solids, but there are different types of solids. So, what are those types? So, we have here first we have the crystalline or crystalline solids, amorphous solids. So, what's the difference between the two? Okay, to try to observe the arrangement of their particles. So for crystalline solids, they have regular arrangement of particles. Okay, they are well arranged. They are closely compact to each other. While amorphous solids, they have irregular arrangement of particles. They are irregularly arranged. Okay, so that's why some other substances they are hard, some are soft. It has something to do with the arrangement of their particles. Some solids can be stretched, okay, and these solids they are amorphous solids. For example, rubber band, it's a solid, but it can be stretched. It has something to do with the irregular arrangement of their particles. So amorphous solids that includes wax, plastics, rubbers. So the arrangement of their particles are irregular for amorphous solids. But for crystalline solids, these are hard objects. Just like for example, we have metals. So they are crystalline or crystalline solids. They have crystal lattice. They have crystallized structure. So aside from that, we also have like diamond. No, it's a form of crystalline solid. It's a crystalline solid. Now, another property of crystalline solid, it has long order in arrangement of particles. So from this side, going to the right side, the particles are well arranged. So that means they have long order in arrangement. While for amorphous solids, this portion only is regularly arranged, but the other portions they are irregularly arranged. So that means they have short arrangement of particles. Okay? So this is for crystalline and this is for amorphous solids. Alright, so let's have another property of crystalline and amorphous solids. Let me admit first your classmates. Okay, again, Properties of crystalline and amorphous solids, regular arrangement of particles for crystalline, amorphous, irregular arrangement. Okay, next we have here true solids and pseudo solids. Now, why do you think we call it true solids? Crystalline solids, they are called true solids, while amorphous solids, we call it pseudo solids. Okay, who would like to answer? You can raise your virtual hand. Okay, again, why do you think we call crystalline solids as true solids and amorphous solids as pseudo solids? Yes, okay. Who was that? Robert.
I think ma'am because amorphous solids like
I'm sorry, Robert, I cannot hear you well. Can you say it one more time?
hello, hello. Madungog
Oh,
na ma'am.
it's okay now.
Okay.
Yes, much
I
better.
think because amorphous solids behave like liquids, ma'am.
Okay, yes, you have an idea. That's correct, Robert. So, amorphous solids, look at the particles for amorphous solids. No? They are not closely compact to each other. So, they are not true solids. While crystalline solids, they have the true property of a solid. So, which is the regular arrangement of particles. Okay? So that's why we call them true solids. So crystalline solids, they are true solids because they have the true property of solids. The particles are closely compact to each other. While amorphous solids, look at their particles. They can flow. They look like the particles of liquids. So for amorphous solids, for example, we have glasses. Okay? Glass is an example of amorphous solid, or sometimes we call it pseudo solids. What do you mean by pseudo? What does it mean?
Semi, ma'am. Semi.
Semi. Okay, what else? Okay, what does pseudo mean?
Not genuine.
Okay, again. It's
Not
up to.
genuine.
Not genuine. Yes, okay. Those na siya, no? Not genuine or false or not true. Okay? So again, crystalline solids, true solids. Amorphous solids, they are false solids or pseudo solids. Okay? Now, they are super cooled. Sometimes we call it super cooled liquids. Now, why do you think we call it super cooled liquids? So, just like glasses. Now, at high temperature, for example, if the temperature is 1,700 degrees Celsius, so at very high temperature, the molecules of glass, they behave like the molecules of liquids. Okay? So, glasses at high temperature, they are similar to liquids. The molecules of them can flow. So that's why glasses are also pseudo solids. Crystalline solids, they have crystallized structure, while glasses, they do not have that structure. Okay, so glasses, remember, they are made from they're made of sand, no? Di-melt na to ang sand. But again, sa iyang molten state, it behaves like a solid. It is similar to, it's similar to liquid. But at room temperature, glass exists as solid. Okay, so glasses, they are amorphous solids at room temperature. But at high temperature, they are similar to liquids. So they have irregular arrangement of molecules. The molecules of glass, they can flow depending on the temperature changes. So that's why we sometimes call it supercooled liquids. Okay, so I have here like trivia. Know how are glasses made? So did you know that glass is made from natural and abundant raw materials, sand, soda, ash, and limestone, that are melted at very high temperature to form a new material, which is the glass? The kind of heat necessary to transform the sand into a liquid state, eventually becoming glass, is much hotter than any sunny day. So we're melting here some raw materials. We're melting sand, soda, ash, and limestone. Okay? The heat needed to melt these materials is 1700 degrees Celsius. So that's the melting point of the sand para ma-change siya into glass. Okay? At high temperature, glass is structurally similar to liquids. So, ang particles sa glass, same siya sa liquid particles at high temperature, just like 1700 degrees Celsius. However, at room temperature, meaning 23 or 25 degrees Celsius, glass behaves like solids. Okay, but glass again is an example of amorphous solid. Okay, another property of a crystalline and amorphous solid. So we have here melting point. Let's compare their melting point. So for crystalline solids, they have sharp melting point, fixed siya. For example, sodium chloride. The melting point of sodium chloride is 801 degrees Celsius. Okay? Fixed siya. But amorphous solids range ang iyang melting point. So what's the melting point of the glass? I mean the sand. The melting point is 1,400 to 1,600 degrees Celsius. Okay, so range siya, no? But sa crystalline solids, fixed or sharp iyang melting point. But their melting points can be changed. It can increase, it can decrease depending on the factors that are involved in it. For example, you are mixing sodium chloride with other substance. Now, other substances can increase the melting point of the sodium chloride. Some other substances can also decrease the melting point. As for here, it can increase to less than 5 degrees Celsius. Okay, for example, imo siyang gimix with other substance, no? Pwede mo increase ang iyang melting point, but less than 5 degrees Celsius. Pwede siya mo decrease, but less than 5 degrees Celsius ang iyang pag-decrease. Sa amorphous solids, pwede pod mo increase siya, but greater than 5 degrees Celsius. Pwede siya mo decrease ang iyang melting point, but greater than 5 degrees Celsius. Okay, see the difference when it comes to their melting point. Crystalline solids, they have sharp melting point. Amorphous, they have range melting point. Okay, next, let's have the next slide. So crystalline solids, they are also anisotropic, while amorphous solids, they are isotropic. Okay, what do you mean by isotropic? Have you encountered these terms before? 1A, isotropic? Yes or not yet? Are you
Not
familiar
yet,
with
ma'am.
isotropic? Okay, not yet. Okay, let me explain to you what the word isotropic mean. Okay, so let's have here, everyone. So crystalline, again, they are anisotropic. When we say anisotropic, meaning these are substances that have a physical property that has a different value when measured in different directions. Okay, so different values but different directions. For example, we have here speed of light. What does it mean? mean? Speed of light. Okay, what does the word speed mean? I think you also have this one in your physics. What does the word speed mean?
Gipaspason no.
Okay, one more time please, Karil.
Gipaspason no.
Gipaspasun. Okay, alright, so that's correct, no? Yang movement or yang gipaspasun. What's the unit of speed? Okay, what's the unit of speed?
Meters per second ba?
Okay, very good. Who is that? Robert?
Yes, ma'am.
Okay, so it's in meters per second. Now, if we're going to get the value of the speed of the light, so remember that light is a wave, no? It travels. So, for crystalline solids, since this is anisotropic, although they have different directions, they have the same, they have different values of the speed of light. Okay, for example, sa kaning direction, so we have here wood. Okay, a wood is an example of crystalline solid. Now remember that woods, they are hard, no? The particles there are closely compact to each other. So they are crystalline solids. So ang speed of light sa right side here, it has different value. Lahi ang value sa speed of light from the right side sa left side niya. Okay? That's anisotropic. If something is anisotropic, meaning that object has a physical property that has a different value when measured in different directions. Since lahi-lahi man ang direction sa movement sa light, so lahi-lahi pod ang iyang speed. Lahi-lahi ang value sa iyang speed of light. Okay? So that's anisotropic. While glasses or amorphous solids, they are isotropic, meaning having a physical property which has the same value when measured in different reactions. When the light travels or the light reaches this medium like glass, as it propagates in a glass medium, no? Same ra ang ilang speed of light in all directions. Okay, the speed of light from this direction, the value of the speed of light from this direction is the same from the value of the speed of light of this direction. Okay? Lain-lain silang direction, no? But same ang ilang value sa speed of light. That's isotropic. Okay? Again, isotropic, they have the same value in different directions. Anisotropic, they have different values in different directions. So, crystalline solids, they are anisotropic, while amorphous solids, they are isotropic. Okay, let's have another one. We have here examples of crystalline and amorphous solids. So examples, crystalline, we have salt. Salt also are crystalline solids. So they have crystallized structure. So iron, it's a metal. It's still a crystalline solid. Gold is a crystalline, while sugar is also a crystalline solids. Amorphous solids, we have glass. So some of these substances, they can be stretched. No, rubber, wax, and sa pa, plastics. So some cotton candy is an example of amorphous solids. So most of these substances, um, they are soft, but again, the arrangement of their particles are irregular and they do not have a crystallized structure, crystallized lattice, okay, compared to crystalline solids. So crystalline solids, there are different types of it. Lain-lain ang crystalline nga solids. So let's have the next slide. So what are the different types of crystalline solids? We have ionic solids. The force acting between these molecules are ionic bonds. Okay, ionic solids, it involves ions. It can be metals or non-metals. So remember, ions, they are atoms or molecules with charges. Okay, so for example, sodium chloride, that's an ion. So it's sodium is a cation, and anion, chlorine is an anion. So non-metals and non-metals are involved in ionic solids. For metallic solids, they are all metals. For example, iron, it's a metallic solid. It's a crystalline solid. Gold is a metallic solid. It's a crystalline solid. Silver also is a crystalline solid. We also have here covalent solids. The force acting on it is covalent bond. Examples, we have diamond and graphite. So these objects, these solids, they are made up of non-metal atoms. For example, carbon atoms. Diamond is made up of carbon. Graphite as well is made up of carbon. Okay? So they are covalent solids. So they are non-metal atoms. For metallic, metal. Covalent, non-metal. Ionic, both metal and non-metal. Molecular solids. For example, we have ice. Ice is a crystalline solid. Okay? Specifically, it's a molecular solid. So when we say molecule, it's made up of two or more atoms. So remember that ice, it's made up of hydrogen and oxygen atoms. So it's a molecule. Okay, it's made up of H2O molecules. Then sugar also is an example of molecular solid. So it's made up of two or more, three atoms, no, different atoms. Carbon dioxide. At room temperature, carbon dioxide exists as gas, but at different temperature, it exists as solid. Pwede ma-change ang carbon dioxide to solid. But again, if in solid form ang carbon dioxide, it's a crystalline solid. Specifically, it's a molecular solid. Okay, see the differences between molecular solids and ionic solids. So ionic solids, they are made up of ions. We have cations and ions. Both, I mean, metals and non-metals. So molecular solids, so they are made up of two or more atoms. Okay? Here, let's compare their properties. Ionic solids, they have high melting points. Metallic, they also have high melting points. That's because of their delocalized electrons. Then covalent solids, they have high melting points. Molecular solids, they have low melting points. For ionic solids, they can be brittle. Metallic solids, they can be malleable and ductile. And then covalent solids, they are hard, and molecular solids, they are soft. Ionic solids, they are insulators in solids. Okay, insulators, that means it's not a conductor of electricity. Okay, dili maka-flow ang electrons if solid sila. So remember, sodium chloride, pwede siya liquid, pwede siya solid. But if solid form siya, insulator. But if liquid form, it can be a conductor. Again, if liquid form or in molten states, they are conductors of electricity. Maka-flow ang electrons when they are in molten states. Sodium chloride, calcium carbonate, and magnesium oxide. We have metallic solids. They are good conductors of electricity. So at home, our wirings, they are made up of metallic solids because they are good conductors of electricity. Covalent solids, they are poor conductors or semiconductors. Molecular solids, they are insulators, meaning they are not conductors of electricity. Okay, questions 1A. Pangutana? None? Everyone, wala pangutana? None. Okay. So let's answer this question, the activity. Do you think these substances are alike? Yes, they are both solids, no? But they also have some differences. The structure of their molecules inside. The cotton candy, again, is an amorphous solid, while the diamond is a crystalline solid. Okay, so we have here reminders. Please check the LMS as per the laboratory worksheet to be used this coming face-to-face meeting. Kindly secure a copy or print a copy, or you may copy it in a short bond paper and bring it together with your lab gown for our laboratory activity this coming face-to-face meeting. Okay, let me explain to you first the your laboratory activity this coming Thursday. Okay, let me share my screen again. You can um you can print it or you can copy it in a short bond paper. Okay, so again, to those who cannot print it, you can copy it in a short bond paper. Just follow the format. Okay, so this is part of your performance task. So please do not be absent this coming Thursday. So this laboratory activity, this is not related to our topic for today, which is the properties of solid. But this is just a guide for you on how to use the burner. Okay? Since some of you weren't able to experience using the Bunsen burner in the chem lab. So that's why I'm giving you this activity. We need to know first how to make use of these apparatus. So students identify the parts and the function of each part of the burner. Students differentiate luminous flame from non-luminous flame. So please bring a pencil because this includes drawing and also a pen. No? It has some questions that you need to answer. Okay, once you're already in the chem lab, everyone, please ask these apparatus and materials for working student. You can write down in a requisition slip. So ask first for requisition slip and then write everything, the apparatus materials. Okay? Then give it back to the working student. So please do not wash them kay dili man ta magamit og test tubes. We're going to use the burner. So no need for you to wash it. Okay, so please read and understand the procedure. For example, we have here assemble the burner and draw it under the observation and interference column. So for example, manaka og assemble sa burner. Okay, we will practice assembling the burner. So you draw it here. And then the burner has different parts. So you need to label the parts of the burner, name each part, and give the function of each part. Okay? You can write it in phrases, it's okay. Then note that the air holes, so the burner has air holes. Ang air hole sa burner, it can be opened and it can be closed. So connect the burner to the gas cock by means of a piece rubber tubing. So sa chem lab, kita mo atong sa table na asya'y metal, no? So that's the gas cock. You're going to connect the burner to that gas cock. Okay? Do not open first. Do not turn on the gas cock first. Okay? Connect the rubber tubing, katong tube or katong hose, no? I-connect siya sa gas cock. And then once you're done, do not open yet the gas. So next, light a match and hold it just slightly above the top of the burner. So light a match again above the top of the burner. Okay? And then slowly open the gas cock. So that's how you make a flame through the burner. So imong sindihan daan ang burner, then hinay-hinayon og open ang gas cap. Now, after that one, you try to open the air holes of the burner. Imo ra tong tuyukon ang air holes sa burner. Ma-open na to siya. And then you try to close it. Now, the color of the flame, it changes when you open or close the air hose. So you draw it here. You draw the flame. If open ang air hose sa burner, unsay color sa flame? You draw and label. If close ang air hose sa burner, unsay color sa flame? So you draw again and label. Now your activity, it also includes luminous flame, comparing luminous flame from non-luminous flame. Now, for luminous flame, dapat close ang air hole sa burner. Okay? For this setup, you're going to use an evaporating dish. So, imong initon ang evaporating dish. Now, inig-init nimo ana na ay black nga substance nga makita. What do you call that black substance? Same anang kanang magsunog ka or kanang sa lamparilla no na siya black na substance. What do you call that black substance? Okay, so you write it in English, okay? Ordinary name. What about the chemical name? So relating to chemistry, what do you call that substance? Okay, and you answer these questions. You write your answers on the left side. Right side, I mean. Okay, for non-luminous flame, you're going to open the air hose of the burner. So, open the air hose. So, if open ang air hose sa burner, blue ang color sa kayo or nearly colorless flame. Okay? Now, note that there seems to be two cones. So, ang kayo na siya'y duha ka cone. Ay ang outside cone and inner cone. So, imong drawingon ang kayo diri. Draw the flame, okay, of the burn. Draw the flame. I-label outer cone and inner cone of the flame. Okay, same goes with luminous flame. You're going to use evaporating dish. Okay, but the difference between them is that here, we use luminous flame, close ang air holes. While for non-luminous flame, blue ang flame, di ba? Then, open ang air hose. Here, since we'll be using evaporating dish, try to observe if naabagyapoy black nga substance nga makita as you heat the evaporating dish. After that one, spray a pinch of powdered charcoal to the flame. What happens to the charcoal? What happens to the color of the flame? So you answer these questions, you write it here. You still need to draw this one. Okay? Sa kandidating na side. Then, another one, we have wet a piece of cardboard. Okay. So wet a piece of cardboard. Do not soak and insert it vertically in the center of the flame so that the bottom of the cardboard touches the barrel, and heat until a drying pattern begins to form on the cardboard burns. Okay, again, dili lumsan ang cardboard. Ang kaning nga cardboard, mura ra ni siya og kanang 1/4 sheet, I mean 1/8 sheet of paper. Ingan na siya kadak ang cardboard. Bas-on nimo dapat ang cardboard. But dili siya lumsan. Dapat dili magtulo-tulo ang cardboard. Kanarang nabasa na siya but wala siya nagtulo-tulo. Okay? So, after that one, i-insert ang cardboard sa flame. Ang flame again na sa burner, okay? Insert the cardboard sa flame. So make sure again nga it's wet. The cardboard is wet. Okay? But this time you're going to insert it vertically. Pabarog siya, di siya pa higda. Okay? Now, once ibutang nimo ang wet nga cardboard sa flame, na ay pattern nga makita. That's a dry pattern, naapod siya wet pattern. Okay? So, with that observation, you can answer the following questions. What part of the flame is the hottest? The inner cone of the flame or the outer cone of the flame? What part of the flame is the coolest? The inner cone or the outer cone? Are you going to touch the flame? No. Again, you need to observe this setup. Okay? This experiment. So, asa nga pattern ang dry, asa nga pattern ang wet. So, that means, if dry siya, meaning, mas init to nga flame. Okay? For example, ang inner flame, no? So, sa flame again, it has inner cone and outer cone. Now, ang wet piece of cardboard, imong gibutang sa flame. Then, ang pattern niya is, ang inside sa cardboard, na ay part nga wet siya, na asay part nga dry siya. So, katong dry nga part sa cardboard, na tumong to siya sa inner flame or inner cone of the flame. Well, katong wet part sa cardboard, naa siya sa outer cone of the flame. So that means si inner flame di ay mas init kaysa sa outer cone of the flame. So that's an example. But again, you need to answer these questions based from your experiment, inyong observation. Okay, draw the sketch of the cardboard showing the dry pattern. Label your drawing. So you draw the cardboard here, then you label asa nga pattern or asa nga part sa cardboard ang dry, asa nga part ang wet gihapon. Okay? So, sa katong dry part sa cardboard, unsa nga flame ang naa dito? Outer cone of the flame or inner cone? Kaya nga naon siya pag-label. Okay? Para ma-compare na to kung kinsa ang mas init, ang outer cone ba sa flame or inner cone. Okay, another setup here will be using matches. Okay, take 2 good matches. But this time, we're going to insert the 2 matches in different parts of the flame. So, dunganon og insert ang duha ka match sa outer cone of the flame and inner cone. Now, observe, kinsay una mo ignite? Ang katong match nga naa sa outer cone of the flame or katong match nga naa sa inner cone of the flame? So you answer these questions. You draw it here and then answer. Okay, same goes with this one, glass tubing. So insert ang glass tubing sa inner cone of the flame and outer cone of the flame. Anyways, we'll do it together this coming Thursday. Once you're done, everyone, never blow out a gas flame. Okay? Dili tayo hupan ang kayo. If you're not using the flame, turn the gas off at the gas cock. Never disconnect the tubing from the gas cock without first turning the gas off. So, dili ditsuon og ibot ang rubber tubing sa burner. Okay? We need to turn off everything first. Turn off the gas of the burner. Always make sure the gas is closed when you are not using it, since this is poisonous. After everything, disconnect the tubing from the gas cut, then return the burner with the rubber tubing to the working student. Okay? Pangutana, 1A.
Excuse me, ma'am.
Yes, Karil.
Ang kanang materials, ma'am, ba kay kami pa'y magkuha na, ma'am, magdala or
Mga yun to sa kuan, Chem Lab.
apil sa aparatus pod, ma'am.
Oh, appeal. Appeal na. Ilista na ninyo. Okay, another question. Yes.
Kuan ma'am. Ma'am,
Yes,
katong
Axel.
kuan ma'am. Katong dishwashing sa una ma'am katong ipadaan mo sa una
Okay.
kay danon to na.
Pwede ra dili. Kay dili ta maghugas ani nga activity. Kay burner, ang focus ata sa burner. The next experiment, magamit na to. But for now, dili sa
So among possible ladon ma'am is lab gun ra o gloves karon.
lab gown. Pwede ra dili duro mag gloves. Yeah,
Sige
ayaw
ma'am,
sa...
sige ma'am. Thank you.
Okay, what else? And girls, please also tie your hair. Kay magsunog ba ta? Okay, wala na? Wala na yung pangutana? 1A?
And so far,
Okay.
siguro, ma'am.
Okay, I guess we're good now. Thank you so much for your time, 1A. Again, it's everything is in the LMS. Please check it. As for your laboratory worksheet, that's individual, but the experiment is by group. Okay, there are only 8 tables sa Chem Lab. So, dapat 8 rapod ka grupo. Okay, thank you so much for your time, 1A. Have a nice day to all of you. See you on Thursday. Thank you and goodbye.
Take care, ma'am.
Bye,
Goodbye,
ma'am. Thank
ma'am.
you, ma'am.